So we have learned three methods of factoring. We know how to factor out a GCF, we know how to factor by grouping, and we know how to apply the AC method. So now we have to consider how can we determine which method to use when. So first, I want to encourage you to always look for the GCF. That should be your first course of action. So let's just review. We have 18V plus 12. This has a GCF of 6. So if I divide my polynomial by 6, my second factor, I get 3V plus 2. Now, once I factor out my GCF, I can look further to see, okay, can I factor further? In this case, that's completely factored. All right, our second example, 6m cubed minus 10m squared. Again, you want to look for the GCF first. So here I can see between 6 and 10, I have a factor of 2. And between m cubed and m squared, we can factor out an m squared. So we have 2m squared is our GCF. Divide by 2m squared to get your second factor. So that gives us 3m minus 5. Then you want to look at 3m minus 5. Could you factor that further? No. All right, now our next example, 5v squared plus 45v plus 90. Now, you might recognize this as a quadratic, and you could factor using the AC method right now, but first I want you to, again, think about, do I have a GCF that I can factor out of the entire quadratic first? So that's not one, shall we say, right? So we want to think about what is the GCF. And so in this case, we actually have a GCF. It's not 1. We can factor out a 5. So I'm going to start with that first. 5 parentheses. Now, if I divide this polynomial by 5, let me give myself a little bit of space here. Okay, divide by 5. Our second factor is 1v squared plus 9v plus, and then 90 divided by 5. So 5 into 9 goes once. All right, we got 18. Okay, so now GCF is 5. That's our first factor. Our second factor is v squared plus 9v plus 18. That factor, we can factor that further. Okay, and here now you have to decide. All right, secondly, we're going to use the AC method. All right, and that's to factor more. All right, so A is 1, so that's great because that makes this a simple, a shortened AC method. B is 9, C is 18. So 1 times 18, remember we want to add to B, which is 9. So 2 and 9, no, 3 and 6. Looks like that's the winner, because 3 plus 6 equals 9. 3 times 6 is positive 18. All right, so now I can factor this further. So I'm going to bring down the 5 and then do 2 sets of parentheses. V squared tells me to do V and V. And then I'm doing plus 3 and then V plus 6. Now I'm completely factored. So if you do not factor the GCF out in the beginning, you'll have to do it later in order to be completely factored. All right, now we have negative 3x to the 4th minus 36x cubed minus 60x squared. So again, I want you to always look for a GCF in the beginning. If you have a GCF that's not 1, so -1, you know, we'll still work with that. But here, we can see, okay, I have a negative leading coefficient. So I want to factor out whatever the GCF is, I want it to be negative. And I'm going by inspection, it looks like we have -3 and then an x squared. So our GCF is -3x squared. We're going to divide by -3x squared. And that gives us 1x squared plus 12x plus 20. Okay. Now at this point, the -3x squared was our GCF. Our second factor, we want to ask ourselves, can I factor this further? So let's look at the AC method. So A is 1 and C is 20. So 1 times 20 gives us 20. Remember, your B is 12. So you're multiplying to 20 and you're adding to 12. So let's do 2 and 10. That looks like that's going to work. So if you try some others like 4 and 5, you see that's not going to work. 1 and 20 would not work. 2 plus 10 gives us 12. Since A is equal to 1, I know I don't need to go any further in the AC method. I know how it's going to factor. Bring down my GCF, and then we have x plus 2 and x plus 10. All right, I want you to pause the video, try this on your own, and then we'll do it together. All right, so I hope that you first look for a GCF. So by inspection, I can see 2 for the coefficients and then x to the 4th. So 2x to the 4th is our GCF. So I'm going to divide by 2x to the 4th to get my second factor. So that gives me x squared minus 10. All right, let me write that a little clearer. There we go. Minus 10x minus 25. Okay. The second factor, I'm going to look to factor that further using the AC method. A is 1, C is -25. So 1 times -25 gives us -25. So what multiplies to -25 and adds to be -10? So -5 and 5? Nope. What about -1 and 25? Nope. What about 1 and -25? Nope. Okay, and you can say, well, what about 5 and -5? That's basically what we have first. So essentially, we don't have a configuration that's going to add to -10. So in this case, the second factor, even though it's a quadratic, we cannot factor this further. Okay, so this is actually done. This is completely factored at this point. All right. Now I want to look at some special quadratics. First one is what we call perfect square trinomial. And so we actually solved these when we were multiplying. when we're squaring a binomial, the result is a perfect square trinomial. A plus b, if we square that, or even squaring a minus b. So when we think we might have a perfect square trinomial, I'm going to show you a method that I like to use when I'm factoring things that I suspect to be a perfect square trinomial. And that is essentially a guess and check method. So essentially, I'm hoping you can see the pattern of when we are factoring, we get two factors, right? And the x squared is determining the term that goes here and here. Something times something gives you x squared. And so in this case, it's x times x. Now we have plus 14x and plus 49. So that tells me I have two plus signs next. Then my plus 49 is influencing what terms are second in each of the factors. So 49, I'm going to guess 7 and 7. Now, the nice part about guessing and checking is if you guess correctly in the beginning, it solves the question very quickly. If you don't, it could take longer. But nonetheless, I'm going to check my work. Okay, so if I multiply out this x plus 7 times the x plus 7, remember you're distributing the x to the x plus 7, that gives you x squared plus 7x. And then you distribute the 7 to the x plus 7, and that gives you plus 7x plus 49. And so then you're left with x squared plus 14x plus 49. So that gives me my original expression so that I know that I have factored this correctly. All right, so my answer is x plus 7 multiplied to x plus 7, or abbreviated squaring the x plus 7. All right, let's take a look at B. We have 25y squared minus 20y plus 4. This is a perfect square trinomial. So if I guess and check this, I can see here, okay, the 25y squared tells me what to put here, right? I'm going to put the same thing, 5y and 5y. Now the minus 20y and the plus 4y tells me to do two minus signs. Because in order to get a positive 4, your signs have to be the same. In order to get a minus 20, those signs has to both be negative. Okay, now the plus 4 tells us what goes here and here. It is 2 and 2. All right, if you multiply this out, you'll notice it does give us our original quadratic, our original polynomial. All right, and we can write this in shortened form, the squaring of 5y minus 2. So you might be wondering, well, why didn't we use the AC method? You could use the AC method if you want to. I'm just showing you how you can guess and check this. Because of the pattern, it's just very quick to be able to guess and check this. So here we have another perfect square trinomial. Go ahead and pause the video, try using the guess or check method, and then we'll do it together. All right, so again, if you're guessing and checking, knowing this is a perfect square trinomial, the 9w squared tells you the two factors that go here, 3w and 3w. And you have minus and plus, so both of these are going to be minus. And then 16x squared tells you what goes here and here. So we have 4x and 4x. So this equals parentheses, 3w minus 4x, close parentheses, we're squaring this. Again, if you want to check your work, go ahead and multiply this out. So if you do the 3w minus 4x times the 3w minus 4x, you're going to distribute the 3w. So we get 9w squared minus 12wx. And then distribute the minus 4x. So that gives us minus 12wx plus 16x squared. All right, and when you simplify this, this gives you 9w squared minus 24wx plus 16x squared, which is our original quadratic. Okay. Another pattern that we saw was when we multiply conjugates. So let's go ahead and multiply a conjugate to remind us what happens. 9u plus 5 multiplied to 9u minus 5. So distribute the 9u to the 9u minus 5. And that gives us 81u squared minus 45u. All right, now let's distribute the plus 5 to the 9u minus 5. So that gives us plus 45u minus 25. And then when you simplify this, the minus 45u and the plus 45u are eliminated. So we have 81u squared minus 25. Hence, when we multiply conjugates, we're left with what we called before a difference of squares. So we have a difference of squares to begin with, 81 minus 64z squared, and we're asked to factor the difference of squares. So if the result is a difference of squares, then you're asked to factor, in other words, to unmultiply the difference of squares, right? You can obviously use the AC method, but I recommend you use what I'm considering a guess and check method because of the pattern. So we know that is going to factor into, if we have a squared minus b squared, it's always going to factor into this pattern of parentheses a plus b, close parentheses, parentheses a minus b. So what that means, the 81 tells me what goes there and there. That's going to be 9 and 9. And then I'm going to do plus and minus. And then the minus 64z squared, that tells me what goes here and there. Again, that's going to be 8z. And I need a little bit of room. Okay, let me move this down just a little bit. There we go. And 8z. And that's it. Right, I'm taking the square root of 81 and I get 9 and 9. The square root of 64 is 8 and 8. The square root of z squared is z and z. That's how I get that. All right, p squared minus 9. All right, go ahead and pause the video and try that on your own, and then we'll do it together. Okay, so again, you can use the AC method for this, but I recommend you use what I call guessing and checking. So p squared tells you what goes there and there. So that's p and p plus and minus. And then minus 9. So 9 tells you what goes there and there. So that gives us 3 and 3. And that's it. Fully factored. Okay, so I keep saying, well, the AC method works. Okay, let's take a look. If you use the AC method here, what that would look like. A is equal to 1. B is actually 0 and C is equal to -9. So we don't have a plus or minus P term, so that's why B is 0. So now A times C is equal to 1 times -9, so we get -9. Now, what multiplies to -9? -1 and 9, 1 and -9, and 3 and -3. I don't need to write -3 and 3 because it doesn't add anything different. So now which one of these factors adds to 0? That's going to be 3 and -3. So if we use the short method, A is equal to 1, so I know this factors into P plus 3 and P minus 3 because there. So you can still use the AC method, or you can use the guessing and checking. All right, if you want to use the full factoring by grouping, you can go ahead and do that. You're still going to come up with two factors of P plus 3 and P minus 3. All right. Now, common misconception is factoring P squared plus 9. Okay, this is prime. Okay, in terms of factoring this into real numbers, this is prime. Okay, it's not factorable when we're considering real numbers. Now, if we were using complex numbers, that's different, but that's beyond this course. Okay, now you might be thinking, well, why can't I do P plus 3 times P plus 3? Well, go ahead and multiply that out. You distribute the P to the P plus 3, and that gives you P squared plus 3P. And you distribute the 3 to the P and the plus 3. That gives you plus 3P plus 9. And when you simplify that, you get P squared plus 6P plus 9, which is obviously not what we're trying to get. So that doesn't work. Okay, or perhaps you think, well, that doesn't work. Well, what about P plus 3 and P minus 3? Well, that's what we got in our previous example. That equals P squared minus 9. That's not going to work. Well, why don't you just go ahead and try the AC method and see if you could come up with something, right? A is equal to 1, B is equal to 0, C is equal to 9. So if I do A times C, that's 1 times 9, which is 9. So if I do 1 and 9, -1 and -9, 3 and 3, or -3 and -3. All of those multiply to positive 9, but do any of those add to 0? 1 plus 9 is 10. -1 plus -9 is -10. 3 plus 3 is 6. -3 plus -3 is -6. So no, we don't get any pairs that give us B equals 0. So this is another check of we can't use the AC method. There is no GCF other than 1. P squared plus 9 is not factorable. That's it. So P squared minus 9, a difference of squares, is factorable. A sum of squares, a sum of squares is not factorable in terms of real numbers. If you want to look up what it factors in terms of complex numbers, knock yourself out. Okay, let's take a look at D. So here we have 18w squared z minus 2z. Now, the only polynomials that we had with two terms were difference of squares. And this is obviously not a difference of squares as it looks right here. But remember what I said before. I want you to look for the GCF first. So looking between 18 and 2, GCF is 2. And then our variables, we can also factor out a z. So let's divide by 2z. Apologize for the horn. All right, so now we have 9w squared minus 1. All right, so 2z, our GCF, good. But can we factor further 9w squared minus 1? Well, this is a difference of squares now. Wonderful. And I want to encourage you to use the pattern that I have been impressing upon you. So using the pattern, we can just guess and check. Using the 9w squared, we get 3w and 3w plus minus, and then the 1, that's so easy, 1 and 1. There we go, we're done. Fully factored. All right, so let's take a look at 3x cubed minus 3u to the 4th x cubed. Go ahead and pause the video, try it on your own, and then we'll do it together. All right, so again, you have two terms. So in general, you have two terms. You want to think about, is there a difference of squares? But do we have a GCF first that we can factor out? So I'm looking by inspection, I can factor out a 3 and an x cubed. Okay, so if I do that, 3x cubed, so divide by 3x cubed, and that gives me 1 minus u to the 4th power. All right, now our GCF 3x cubed, we're done with that. But our second factor, 1 minus u to the 4th, can we factor that further? And we can, because that is a difference of squares. Okay, so I'm going to bring down the 3x cubed, and for the 1, that is telling me what to put here and here. 1 and 1, and then plus and minus. Now, what about u to the 4th? Well, that tells me what to put second. It's going to be u squared and u squared. Okay, now you might be quite pleased with yourself if you got this far, but we actually are not done. Okay, 3x cubed is factored. The next factor, 1 plus u squared, that's completely factored. But the third factor I have written, the 1 minus u squared, that actually is not fully factored. That's still a difference of squares, and we can factor some more. So I'm going to rewrite the 3x cubed, and then the 1 plus u squared, and then we're going to factor the 1 minus u squared. So we're going to get 2 more factors. So factoring the 1, we get 1 and 1, and plus and minus, and then factoring the u squared, we get 1u and 1u. All right, now we're going through to each factor. I can see now we are fully factored. So once we are fully factored, I can see I have 4 factors in my final answer, and we are done.